Okay, today we are going to start with chain rule. First, we are going to define chain rule and we are going to use chain rule to find the derivative. Chain rule is used to find the derivative of composite function. When I say composite function, if you see a function inside the other function, then it's called composite function. For example, if y is equal to f of g of x, then you can see that function g of x is inside the function f, where y is equal to f of u and u is equal to g of x. That's the other way of writing it. So if I write f of u, then u is g of x. So in this case, this function is a composite function. And if you want to find the derivative of the composite function, when you see a function inside the other function, that's the composite function, we use chain rule. And there are two ways of writing the chain rule. The first one is derivative of y with respect to x equal to dy over du, because you may write y as f of u. So dy over du multiplied to du over dx. So this is the first form of the chain rule. The second and widely used form of the chain rule is here. Derivative with respect to x of f of g of x. F is the outside function. G of x is the inside function. So if you are finding the derivative of composite function like this, it is equal to the derivative of outside function. You can see f prime x, derivative of outside function, keeping the inside function as it is, g of x as it is, multiplied to the derivative of inside function. So first we find the derivative of outside, keeping the inside same, and then we multiply by the derivative of inside function. This is the chain rule. We'll be using the second version of the chain rule to solve the problems in upcoming slides. So this is the basic idea about chain rule. Example, find the derivative of the following functions using chain rule. Here we have 4 functions and we have to find the derivative of each of these. First, let's work on part A. So in part A, our function is y equal to 5x minus 12 raised to 3. So you can see that your inside function is 5x minus 12 and your outside function is a cubic function. So to find the derivative, dy over dx, we are calculating the derivative with respect to x is equal to the derivative of outside function. So derivative of the cubic function, you know that to find the derivative of cubic function, we use the chain rule. So in chain rule, we bring this 3 in front and then we reduce the power by 1. That is the chain rule. That is the derivative of outside function multiplied by the derivative with respect to x of inside function, which is 5x minus 12. So we use the chain rule. You can see this is the composite function. So derivative of outside function multiplied by the derivative of inside function, which is equal to 3 times 5x minus 12 is squared multiplied to, now derivative of 5x, 5 is a constant multiple, so 5 multiplied to derivative of x is 1 minus derivative of this constant is 0, which is equal to, now you can see here 5 times 1 is 5, 5 minus 0 is 5. This is multiplied to this number here, which is 15. And then we have 5x minus 12 quantity squared. So that is the derivative of the function y equal to 5x minus 12 raised to 3. Here we use the chain rule to find the derivative because this is a composite function. Your outside function is a cubic function and inside function is 5x minus 12. Okay, now let's work on part B. In part B, we have y equal to the square root of 5x squared plus x minus 3. So you can clearly see this is a composite function. Your outside function is the square root function, and the inside function is 5x squared plus x minus 3. So if you have an inside function and outside function like this, we use the chain rule. So dy over dx, the derivative is equal to the derivative of outside function. Outside function is a square root function. And we know that the derivative with respect to x of square root function of square root of x is 1 over 2 square root of x. That's what we know from previous class. So the derivative of outside function will be 1 over 2 times the square root of whatever is there, 5x squared plus x minus 3. So that is the derivative of outside function. Multiply that with the derivative of the inside function. Inside function is 5x squared plus x minus 3. Now let's simplify this. So we have 1 over 2 times the square root of 5x squared plus x minus 3 multiplied to, now derivative of 5x squared, 5x squared, 5 is a constant multiplying to x squared. So in constant multiple, we keep that 5 as it is. Then square root, the derivative of x squared, we use the power rule. So we bring that power in front and then reduce the power by 1. 2 minus 1 is 1, x raised to 1. Then plus derivative of x with respect to x is 1 minus derivative of this constant is 0. So what we get is, in the numerator we have 1 multiplied to that quantity, which is 5 times 2, 10x plus 1. So in the numerator I have 10x plus 1, because this is 5 times 2, 10x plus 1 minus 0, so that's just 10x plus 1. This is multiplied with 1, so 10x plus 1. And in the denominator, I have 2 times the square root of 5x squared plus x minus 3. So we simplified enough to get this one, so we don't need to simplify this anymore. So this is the derivative of the function y equal to square root of 5x squared plus x minus 3. We use chain rule to find the derivative of this function because it is a composite function. Your inside function was 5x squared plus x minus 3, and your outside function was the square root function. Now we are going to work on part C. Let's see what is given in part C. In part C, we have y equal to e raised to 3x, that's exponential function, multiplied to 3x squared minus 1, quantity squared, an exponential function multiplied to the algebraic function. Now we can clearly see this is the product of two functions. So if it is a product, the first thing we need to do is use the product rule. And if you remember the product rule says the derivative of first function times the derivative of second plus second function times the derivative of first. So let's write that. dy over dx, the derivative is equal to first function e to the 3x multiplied to the derivative with respect to x of the second function 3x squared minus 1 squared plus second function, which is 3x squared minus 1 squared times the derivative with respect to x of the first e to the 3x. So we use the product rule in the first step. So e to the 3x, we are not doing anything to that, e to the 3x multiplied to, here we have derivative with respect to x of 3x squared minus 1 quantity squared. That means we are finding the derivative of this composite function. This function is composite function because it has the outside function, which is a square function, and also it has the inside function 3x squared minus 1. So in order to find this derivative, we have to use the chain rule, which says the derivative of outside function, the derivative of outside function will be, you bring that 2 in front and then reduce the power by 1. So when you reduce the power by 1, 2 minus 1 is 1. Then by the chain rule, we multiply by the derivative of inside function. Inside function is 3x squared minus 1. 3x squared minus 1. Then we have this plus 3x squared minus 1 quantity squared multiply to derivative with respect to x of e to the 3x. Now here you can see this is not e to the x, instead it is e to the 3x. So this is also the composite function. So your outside function is e to the 3x and inside function is 3x. And we know that from the previous class, the derivative of e to the x is e to the x. So derivative of outside function will be e to the 3x multiplied with the derivative with respect to x of inside function, which is 3x. So here I use chain rule to evaluate this derivative and this derivative here. Okay, this is equal to e to the 3x multiplied to, we have 2 times 3x squared minus 1. And then here, if you look at this carefully, this is 1. Derivative of 1 is 0. Now here we can use the power rule. In power rule, we bring this power down here. So it will be 3 times 2, which is 6. And then we reduce the power by 1. Here we have x squared. So when you reduce the power by 1, it will be x. Then plus we have 3x squared minus 1 quantity squared, which is this one, multiplied to e to the 3x. And then again multiply to here the derivative of 3x. 3 is a constant. Derivative of x is 1, so it is just 3. First, I'm going to simplify this first term here, this much. So if you look at that carefully, here we have 2 times 6x, which is 12x, or yeah, 12x. And then here we have e to the 3x. And also I have 3x squared minus 1 inside the parenthesis. 3x squared minus 1. Then plus, now if you look at the second term there, that is a 3 e to the x, okay, 3 e to the 3x. And then I have 3x squared minus 1 quantity squared. 3x squared minus 1 quantity squared. Now in these two terms, if we look at it carefully, e to the 3x is there in both, so that is a common factor. E to the 3x is common. Similarly, here is a 3, here is a 12. So 3 is common. 3 is common. Also, here I have 3x squared minus 1, and here I have 3x squared minus 1 quantity squared. Meaning of that is, here I have 3x squared minus 1, one of them. Here I have 2 of them, so one of them is common. So let's factor that out. 3x squared minus 1, factor that out. Now let's see what is remaining from the first. This is factored out, this is factored out. Now we have factored out 3 from here, so 4x is remaining there. 4x. And then this plus sign from the middle, 3 is factored out. E to the 3x is also factored out. From here, one of the factors is taken out, so I'm left with 3x squared minus 1. So now my final answer will be 3 e to the 3x. Then I have 3x squared minus 1. Then here we have 3x squared. Then we have a 4x and then minus 1. So that is the derivative of the function y equal to e to the 3x multiplied to 3x squared minus 1 squared using the product rule and also the chain rule. Okay, part D. In part D, we have y equal to 5x squared divided by 3x squared minus 5 quantity squared. So when you look at this carefully, you have this inside function here, which is 5x squared over 3x squared minus 5. That's your inside function. And you have an outside function that is a squared function. So this function is a composite function. This is composite function. And you know that to find the derivative of the composite function, we use the chain rule. So let's use the chain rule. So dy over dx is equal to, chain rule, we bring the power in front because we want to find the derivative of outside function first. Outside function is the power function, so we bring that 2 in front, and then we reduce the power by 1. When you reduce the power by 1, it will be power 1 or just like that. So that is the derivative of outside function. Multiply by the derivative of inside function, derivative with respect to x of the inside function is this one. 5x squared over 3x squared minus 5. So that is the chain rule. We use the chain rule here in our first step. So this implies the derivative with respect to x is equal to, we have 2, we have 5x squared over 3x squared minus 5. Now let's use the quotient rule. Quotient rule says denominator, which is 3x squared minus 5, 3x squared minus 5, multiplied with the derivative of numerator. Now I'm going to directly write the derivative of numerator. Derivative of 5x squared, 5 is a constant. For x squared, you use the power rule, so that 2 will come here down. So 2 times 5, 2 multiplied to 5, that will be 10. We reduce the power by 1, so it is x squared, it will just be x. So I did denominator, which is this one, multiplied with the derivative of numerator. Now minus the numerator. The numerator is 5x squared, multiplied with the derivative of denominator. Now here I have to write the derivative of denominator. If you look at the denominator, the derivative of 5, it's a constant, so that will be 0. But the derivative of this one, 3x squared, will be 2 will come in front by using the power rule. So 2 times 3 will be 6. And then we reduce the power by 1, so it will be x. All divided by the square of the denominator. My denominator is 3x squared minus 5. When you square it, it will be 3x squared minus 5 quantity squared. That is my second step. Next step will be derivative with respect to x is equal to, here we have 2 times this quantity, so 2 is multiplying with the numerator, so 2 times 5 will be 10x squared, divided by, in the denominator we have 3x squared minus 5, then multiply 2. Over here, if I distribute that 10x, 10 times 3 is 30, and x times x squared is x cubed. Then if I multiply here, it will be minus 10x times 5 is 50x. Then minus 5x squared multiplied to 6x is 30x cubed over, we have 5x squared minus 5 quantity squared. So dy over dx is equal to, now let's simplify that. Here we have 30x cubed minus 30x cubed. They get cancelled. Then after that, we have the 2 fraction in multiplication. This is my first fraction. Second fraction is negative 50x over that. So whenever we are multiplying fraction, we multiply numerator with numerator. So 10x squared multiplied to negative 50x is negative 10 times 50, 500. And then x squared multiplied to x is x cubed, divided by, in the denominator, 3x squared minus 5, that's one of them, multiplied to, this is 3x squared. I wrote 5. Look at that. That is 3x squared minus 5 again. So when you multiply these two, here we have 2 of them, here we have 1 of them, so you'll have 3 of them, which is 3x squared minus 5 quantity cubed. And that is the derivative of this function, y equal to 5x squared over 3x squared minus 5, the quantity squared. So in order to find the derivative, we use the chain rule and the product rule. After that, it's a quick simplification using basic algebraic rules. Example, if y equal to f of g of x, that's the composite function, use the table below to evaluate the derivative. Here is the table given. We have the value of x, the value of the function at these values, value of g of x at that value, 1, 2, 3, 4, and then we also have the derivative. We have to find the derivative at 1 and derivative at 3. So this is the composite function. If you want to write the derivative of this function, what we know is the derivative with respect to x is equal to the derivative of outside function. So it will be f prime, keeping the inside same, multiplied by the derivative of inside function. So that is our chain rule. So in part A, we want the derivative with respect to x at x equal to 1. That means we want to find this when x is equal to 1. So if you plug in 1, see, it will be f prime. I'm plugging in 1 over here. So f prime g of 1 multiplied to g prime x is 1. So this is equal to f prime, the value of the function g at 1. Function g of x at 1 is 4. So g1 is 4. Multiplied to g prime at 1. This is g prime. G prime at 1 is 2 from the table, equal to f prime 4. See, f prime is here. When x equal to 4, f prime 4 is negative 8. Multiplied to 2, that is equal to negative 16. So the derivative of the function, of this function, at x equal to 1 is negative 16 by using the chain rule. Now let's work on B. We have to find the derivative, the same thing, when x equal to 3. So we are going to plug in 3 over here. So this is equal to f prime g of 3 multiplied to g prime 3, which is equal to f prime g, the value of the function g at 3. Here is g. When x equal to 3, it is 1. So that is 1. Multiplied to g prime at 3. This is g prime. At 3, it is 20. That is equal to, now I need f prime 1. Here is f prime. And at 1, f prime is 5. So it becomes 5 times 20, which is equal to 100. So the derivative at x equal to 3 is 100. Example, determine the equation of the line tangent to the graph of the function f of x equal to x multiplied to the square root of 5 minus x squared at the point x equal to 1 on it. So what I want to do first is I want to sketch the graph of this function. If you need calculator, you can use calculator and then sketch. So let's sketch the graph. First, I'm going to draw the x-axis and then the beautiful y-axis. And you may want to use your calculator to graph. So suppose that is my x-axis, this is my y-axis, and the graph of this function, x multiplied to square root of 5 minus x squared, will be a beautiful function that looks something like this in your graphing calculator. And we want to find the equation of the tangent line at x equal to 1. So the point on the graph when x equal to 1, your x equal to 1 is somewhere here. So that will be the point on the graph. And over there, you want to find the tangent line. So your tangent line will be something like this. This is your tangent line. And we want to find the equation of the tangent line. Now you can clearly see if you extend this tangent a little bit, if you extend this tangent a little bit like that, you can see that the y-intercept is positive. Okay, it is above the x-axis, so y-intercept is positive. And also when you go from left to right, the tangent line is going up. That means the slope will be positive. That is what we know. So in order to find the equation of tangent, we know that we need a point and the slope. So first, let's find the point. Point of tangent C. It will be, your x is already given, x is equal to 1. And y is equal to how much? You plug in 1 into the function. So this is my function, which is f of x equal to x times the square root of 5 minus x squared. So if you plug in 1, you'll see it is 1 times the square root of 5 minus 1 squared. So 5 minus 1 squared is 1, and 5 minus 1 is 4, square root of 4 is 2, 2 times 1 is 2. So that is f of 1 is equal to 2. So point of tangency is 1, 2. That means this point on the graph, that is 1, 2. That is the first thing. We got the point. Next, we need to find the slope. And slope is the derivative at x equal to 1. So let's find the slope. For the slope, we find the derivative. So the derivative of this function will be f prime x, that's how we write, is equal to, you can see this is the product of two functions. X is one function, multiplied to the square root of 5 minus x squared, that is the other function. So it is in the form of product, so we have to use the product rule. And product rule says first function, which is x, multiplied to the derivative of the second function, derivative of that, plus the second function times the derivative of first. Derivative of x is just 1. So f prime x is equal to x multiplied to, now in order to find the derivative of this one, derivative with respect to x of square root of 5 minus x squared, here you have to use your chain rule because your outside function is a square root function, inside function is 5 minus x squared. Now the derivative of outside function, the square root function is, you know that it is 1 over 2 times the square root of whatever is there inside, multiplied by the derivative of inside function. Derivative of 5 is 0 minus something negative. And derivative of x squared by using the power rule, bring that power down and reduce the power by 1. So 2x. Plus the next one is square root of 5x squared minus 1. That is square root of 5 minus x squared. Just that, square root of 5 minus x squared multiplied to 1 is square root of 5 minus x squared. So that is the derivative in not simplified form, but that is the derivative of the function using the product and then chain rule. Okay, so we want slope. So slope will be, slope m is equal to, you plug in x equal to 1. If you plug in x equal to 1, that is 1 multiplied to 1 over 2 times the square root of, you have 5 minus 1 squared is 1, multiplied to negative 2 times 1, plus the square root of 5 minus 1 squared is 1. So we need to simplify this to get the slope. In the first one, you can see here I have negative 2 times 1. Negative 2 multiplied to 1, that is negative 2. Divided by, in the denominator, I have a 2 here. And then multiply to square root of 5 minus 1 is 4. The square root of 4 is also 2. Then I have a plus. And then square root of 5 minus 1 is 4. Square root of 4 is 2. So this implies the slope is equal to, if you look at this little carefully, you can see 2 and 2 cancel. So it becomes 1 in the numerator, 2 over 2 is 1. So 1 in the numerator, 2 in the denominator, that's a half, and it's a negative half. So now, if you read this carefully, this is 2 minus half. 2 minus half is 1.5 or 3 over 2. So the slope is 3 over 2. Now let's find the equation of tangent. Equation of tangent is y minus y1 is equal to m times x minus x1. That's the formula. So let's plug in the values. Y minus y1, this point is x1, y1. y1 is 2. Slope, we got 3 over 2. X minus x1, x1 is this point, which is 1. So y minus 2 equal to, if I multiply 3 over 2 multiply to x, that is 3 over 2x, then minus 3 over 2 multiplied to 1 is 3 over 2. This implies y is equal to 3 over 2x. If I add 2 on both sides, these 2 will get cancelled here, but here I have 2 and then minus 3 over 2. So y equal to 3 over 2x. 2 minus 3 over 2. 3 over 2 is 1.5. So 2 minus 1.5 is 0.5 or half. So this is the equation of the tangent line. You can clearly see it has a positive slope because when you go from left to right, the tangent line is going up. And it has a small positive y-intercept. From here to here, it's half. That is the meaning of that. So this is how we can find the equation of tangent line. Always remember, to find the equation of tangent line, we need the point. If the complete point is not given, first we have to find the point. And then we have to find the slope. Slope is the derivative of the function at that particular point. So we find the derivative and substitute that point to get the slope. So once you have the slope and the point, we have the equation of the tangent line using this point slope form.